So when we're talking inverse operations, we're really talking about anything that you would use in an algebraic equation to undo something else. So addition and subtraction would be inverse operations, multiplication and division, taking the square root of something and squaring something. And then for what we're going to talk about today, if we had a trig function like sine of x, in order to undo that in an equation, we would use the sine inverse of x, which we're also going to call arcsine. We're going to focus on sine and cosine for these, but they are going to look the same notation-wise. They're treated a little bit differently. We can have the inverse cosine of x, or the arc cosine of x would be the inverse of cosine. So before we get into examples that use arcsine and arc cosine, I first want to talk about some restrictions that we have on these functions that we don't have on sine and cosine. We can plug in whatever we want into sine and cosine, but arcsine and arc cosine are a little bit different. So let's look at sine of x equaling 1/2, and then also sine of x equaling a negative 1/2. For both of these equations, we're asking ourselves, what angle could I take the sine of that angle and get positive 1/2? What angle sine of that angle is a negative 1/2? And we've done problems like this before where they tell us that the degrees are in between 0 and 360 or 0 and 90 so that we know what quadrants we're allowed to use. But if we're just given the equation like this and we're not given the domain for x, then there's actually a specific way that we have to solve them. So to explore this, if I'm actually going to use algebra and not just knowing the angle that's going to give me 1/2, if I'm going to use algebra, that means that I'm taking the sine inverse of both sides to get x by itself. So when I take the sine inverse of sine, that gets x by itself. But then on the right side, I'm going to have sine inverse of 1/2. Same thing for this one. Sine inverse of sine is just x, but I'm going to have the sine inverse of a negative 1/2. And we're going to use our calculator to see what happens with this. Is it just going to give me pi over 6, or is it going to give me the pi over 6 and 5 pi over 6 for that second quadrant that is also positive for sine? So we're just taking the sine inverse of a positive 0.5. It's going to tell me 0.523, something like that. And to just kind of check what this is talking about, we thought it was pi over 6. So just checking, pi over 6 is that 0.523. So it is telling me just pi over 6. So what's interesting here is that it's not giving the 5 pi over 6 in the second quadrant. In fact, my scientific calculator doesn't have a way to give me two solutions. But anyway, when sine is positive, it's just giving me the first quadrant. So kind of keeping that in the back of our minds. With our negative, something even stranger is going to happen. So if I'm taking my sine inverse of a negative 0.5, it gives me a negative 0.523, which we just found was pi over 6. But instead of giving me an angle that is positive in the third or the fourth quadrant, this is in the fourth quadrant, but it's a negative angle. So the calculator is not malfunctioning or anything. We do have a good explanation for this. And to figure out the restrictions on our arcsine, we're going to look at sine, because we are talking about an inverse in the sense that all of the x's and y's are switched, domain and range are switched. So let's look at what's happening graphically. Because for our sine of x, notice that it passes that vertical line test. It is a function, but it doesn't pass the horizontal line test. So that means for my sine inverse, I'm going to run into some issues here. So for each one of these points, I'm going to switch my x and my y. So for 0, 0, it's still going to be at 0, 0. But for my pi over 2, 1, now I'm going to be at 1 pi over 2. And then when I go back down to this pi 0, that means that I would here be at 0 pi. So if I did graph the 0 pi, then this would not be a function anymore. So what happens is that we actually stop here and we don't continue on to pi. So anything after pi over 2, we just kind of say Okay, I can't go that direction because then it's not going to be a function anymore. It's going to come back above the piece that I already have. But instead, I'm going to go the other direction and say that my negative pi over 2 is normally at a negative 1. So that means that for my inverse, I'm going to have negative 1, negative pi over 2. So I've got this point right here. And the same issue is going to happen if I continue going back up with this, then I'm going to have my function back close to the y-axis, and so it's not going to be a function anymore. So this ends up looking like something like this, where my domain for arcsine or sine inverse is just going to be in between -1 and 1. Which makes sense because I'm putting in a ratio and then getting out the angle that gave me that ratio, but for our unit circle, we don't have any ratios that are greater than 1 or less than -1. So that would make sense if I plugged in a ratio that was greater than that or less than -1, it wouldn't make any sense. And then my range for the values that are going to come out of that, this is the part that's a little bit strange. Because my domain was restricted, my range is restricted to this negative pi over 2 to pi over 2. So what that means for my arcsine is that anytime I'm putting in a ratio, the angles that I'm going to get out of that are only going to be angles that are in the first or the fourth quadrant. So I'm not going to have that included at all. And not only that, but in the fourth quadrant, it's always going to be a negative value. So I'm either going to have the positive version. If my ratio was positive, then I'm going to have the positive angle. If my ratio is negative, I'm going to have a negative angle. So if we were to look at maybe sine of x equaling radical 3 over 2, so since it's positive, we know that if we take the inverse, we're going to get that angle in the first quadrant. So that tells me that my x is a pi over 3. Whereas if I have sine of x equals a negative radical 3 over 2, I know that the reference angle is still pi over 3, but it's going to be in the fourth quadrant and it's going to be negative. So I'm going to have a negative pi over 3. All because of this restriction on the graph, that I have to have a domain in between -1 and 1. I have to have a range in between negative pi over 2 and pi over 2. So we're going to have restrictions on cosine inverse as well, but they are going to look a little bit different because there is a different place here that cosine is not passing the horizontal line test than what we saw for sine. So same thing we did with sine, we're going to go ahead and take the inverse of these different points and just see what happens. So I'm going to have the point 1, 0. I'm going to have the point -1 pi. And then after that, notice that after this piece, that's where it starts not passing the horizontal line test. So if I keep going right here, that's where this is not going to be a function anymore. It's going to go back above. If I go the other direction and continue my cycle negative, then it's still going to have that same effect. It's not going to pass the horizontal line test. So this is my full piece for arc cosine. So it's going to look something like this, and this was definitely not to scale because my pi ended up being the same length as like 1 and -1, and it's 3.14. So, but anyway, that gives us the gist of what this looks like, and what this tells us is that our domain for arc cosine, we're going to have that same -1 to 1, because again, because of our unit circle, we're not going to have any ratios outside of that. But this time my range is going to be from 0 to pi. So where my arc sine only gave answers that were in the first quadrant or the fourth quadrant, arc cosine is only going to give answers that are in, since we're going from 0 to pi, it can be in the first quadrant or the second quadrant. So just like for sine, when we had a negative ratio, it automatically told us that we were in the fourth quadrant. This is going to do the same thing, where if cosine is positive, we're automatically going to be in the first quadrant. If cosine is negative, we're automatically in the second quadrant. So for example, if they asked us cosine of x equals radical 2 over 2, and cosine of x equals a negative radical 2 over 2. So if they're not going to give us a domain for x, if they're not going to tell us what values we're allowed to have here, then we have to use arc cosine. And that's going to tell us that when I take the inverse of my radical 2 over 2 arc cosine and that tells us that when I take the arc cosine of radical 2 over 2, that I'm automatically going to be given something in that first quadrant because cosine is positive. So this is going to say just a pi over 4 for my answer. For cosine equaling a negative radical 2 over 2, again, they're not giving me that 0 to 2 pi, so I'm not giving both answers, but just solving it with what I've been given. Automatically, since cosine is negative, it's going to be in the second quadrant. And when I'm solving this, I know it has a pi over 4 reference angle, but then I would have to know in the second quadrant it's going to be a 3 pi over 4. So for any of our examples that are involving inverse trig functions, we just want to make sure that we are giving answers that are in the quadrant that we are allowed to be in for that trig function. So for arc sine, immediately when I see this, I'm thinking, okay, arc sine only exists in the first and the fourth quadrant. So if the ratio they're giving me is negative, that means I'm in the fourth quadrant. And then I would just have to know that my reference angle for sine being radical 2 over 2 is pi over 4. But since we're in that fourth quadrant and our range is that negative pi over 2 to pi over 2, it would have to be a negative pi over 4. We could have something that involves an inverse trig function, but also finding another trig function. And really what this is asking is if you have this ratio for sine, we're going to have some angle that comes from that, but we don't necessarily need to know what the angle is, because then we're going to be finding the ratio of tangent of that angle. Okay, so first of all, for arc sine being positive, that means that we're in the first quadrant. So if we want to get a good idea of what's happening, we can go ahead and draw our triangle in the first quadrant. If arc sine is 2 over 3, that's saying for that angle, the opposite over hypotenuse is 2 to 3. And then we're finding tangent of that same theta. So we don't necessarily have to find it, but we do have to find tangent of that. So we're solving for that missing side using Pythagorean theorem. We're going to get radical 5 for that missing side. So now my tangent of the arc sine of 2 to 3 is just going to be tangent of this theta, which is my opposite over adjacent. So 2 over radical 5, which is 2 radical 5 over 5. Same thing for this last one. Pause the video for a second and just see if you can decide what quadrant it's going to be in for arc cosine being negative. What we've learned is that arc cosine only exists in the first and the second quadrant. So if my arc cosine is a negative ratio, that means it has to be in the second quadrant because cosine is positive in the first quadrant. So we're looking at, since a cosine is negative 3 over 5 for theta, we know that that x value is a negative 3. Our hypotenuse is a positive 5. Same thing that we did on example 2, we're finding that side that we're missing, and this is a 3, 4, 5 triangle, so I'm going to go ahead and use the shortcut there, but you could use Pythagorean theorem to find that other side. And then that just tells us, because I knew what quadrant we're in, sine is going to have to be positive. So my sine of arc cosine of negative 3 over 5 is just going to be 4 over 5.